To the demo of a PRML project named AlgoViz. This platform is designed to explore and implement machine learning models for pattern recognition and data analysis. Today, I'll walk you through two supervised learning models and two unsupervised learning models that we have worked on. Uh, let's move on to the supervised learning models. Firstly, let's see how linear regression works. So to give you the demo data, I'll load a sample data. Let's keep the number of samples 65 and let's generate a sinusoidal wave pattern. This is the generated data. Let's run polynomial regression on it with degree 1, which means it's linear. Uh, this model is a classic supervised learning algorithm used for predicting continuous outcomes. For example, it can predict house prices based on features like area, number of rooms, and location. It works by finding the best fit line that minimizes the error between predicted and actual values. Now let's run the regression model. So see, this red line here depicts the best line. Let's play the video and see how it is achieved. You also have a toggle for speed, so you can switch it from, you can have the speed slow and fast both. So this line that we have is the best fit line for this scenario. All the results, the equation of the line, the R2 score and the mean squared errors are also calculated by our model. Now let's move on to the next supervised learning model, that is SVM, support vector machine. Let's also load sample data in this. You can select all these fields for sample data. So this is our sample data which we have made. Currently we are in training mode, so let's run SVM. This finds SVM is widely used for classification tasks. It separates data points into different categories by finding an optimal hyperplane. For instance, it can classify emails as spam or not spam based on their content. Uh, uh, Now, if you switch the interaction mode to prediction points, you can add points on the graph that we have, and you can predict points like these ones are of red class and these ones are of blue class. Uh, the accuracy and support number of support vectors is also calculated by our model. Now let's move on to the unsupervised learning models. First we'll use, I'll show you k-means clustering. We'll also generate sample data for k-means clustering. This algorithm groups data points into clusters based on their similarities. For example, it can segment customers into groups based on their purchasing behavior without needing labeled data. Now let's run k-means clustering. The animation you are showing, you are getting shown is of the centroids of all different groups getting separated. It gives all the result like inertia and silhouette score of the uh, sample data that we have used. Now let's move on to the next unsupervised learning model, which I'll show you, which is PCA, Principal Component Analysis. We'll again generate sample data. Let's keep the number of samples 85. You can also manually add data points if you want, or by interacting with the graph. Let's compute the principal component analysis. PCA or principal component analysis reduces the dimensionality of the data while retaining its essential features. It's often used in image compression or to visualize high dimensional data sets in a simpler form. So these are the eigenvalues and eigenvectors calculated. And you can also view the projecting points. Uh, The correlation matrix and other fields are also calculated by our model. So this was our demo video for our project AlgoViz. Thank you for watching this demo. Feel free to explore about these models and implementation on our website www.algovizz.web.app. Thank you.